operations and positive and negative numbers. So we talked about that PEMDAS and please excuse my dear Aunt Sally. And so then we realized that if I'm looking at that, the first thing I have to do on this one is what? Parentheses. Good, because parentheses always come first. I'll write out order of operations. Please excuse my dear Aunt Sally. Okay, so I'm starting here, and I have 7 plus negative 4. So I have $7 in my pocket. I owe someone 4. After I pay them, I have 3. And this is divided by a negative 3. When we say parentheses mean work everything inside of it. There's nothing to work inside of that. So it's just a negative 3. Okay, so then I just divide, and remember my rules for division. 1 negative makes it negative, so it's negative 1. Okay, next one. So I should know that in PEMDAS, we have parentheses, exponents, multiply or divide from left to right. So on this one, I actually need to do that first because that's the division. So negative 9 divided by negative 1 is a positive 9 plus negative 4. And then I add those together to this side. I owe someone $4, but I have 9 in my pocket, so I have a total of 5. Okay, and the next one, I've got to start with the parentheses. So here's my parentheses right here. I have negative 9 plus negative 3. So basically, I owe someone negative 12. But I still have this negative 1 minus. So I have negative 1 minus that. So now I'm going to go ahead and do my same change. Hey, Mr. Sherman. My keys?
Yeah.
Keys? Oh, answer keys.
Chapter 5.
Yeah, they're in there.
I'll get around
Okay,
this.
you just have to.
Hello.
Hello. Okay.
Hi.
All right, and so then if I owe someone $1, but I have 12, then I have 11 in my pocket. Okay, questions on those 3? Good? All right. All right, so moving on to our learning goal today. So today we're going to focus on all the operations. This is the second day on 5.5, and we're going to look at some different types of problems. First one is going to be a word problem with Fahrenheit and Celsius. Okay, do you guys know the difference between those two? What's Fahrenheit? No one? You know what Fahrenheit is? Yes. Yeah, the way we measure temperature.
Oh, yeah.
Yeah. Very good. So it's 61 degrees outside. We just don't say it's 61 degrees Fahrenheit. We don't say that. So what's Celsius? Science way. Okay. The way everyone else in the world does temperature except us. Okay, so if they say it's 10 degrees outside, then you might want to know, well, I don't know, is 10 degrees cold or is it not? Because to us that's cold, right? Okay, so there is a conversion for that. And if you want to know what 10 degrees Celsius would be in Fahrenheit, we can use this little formula. Okay, so we're going to start out with our formula. 9/5 C plus 32. And then we're going to put in that negative 10 for Celsius right here. So I'm going to erase the C and put in negative 10. Okay. Order of operations tells me to do what first? I taught you oh so well. What do I do first? Oh, come on. You guys know multiply, right? Okay. Can I multiply 9/5 times negative 10?
Yes.
Yeah, you just put the 1 under it. I taught you how to do this. So put your 1 underneath it. Look for anything you can cross cancel, right? Is there anything I can cross cancel? 5 and 10, good. So 5 goes into itself once, 5 goes into 10 2 times, good. And so we have 9 times a negative 2. 9 times negative 2. Negative 18, and this would just be a 1 and a 1. So do I need to put a 1 underneath it? No, I don't have to. So plus 32 equals Fahrenheit. Now what do I need to do? Add them, but technically subtract them because they're different signs. So what is 32 take away 18? What is that? 14? 4, 1? I'm getting 14. Is that what you guys are getting? And would it be positive or negative? Positive because the 32 is bigger. So if they say over in Europe it is a minus 10 degrees Celsius, you're like, I don't know, is that cold? That would be 14 degrees, our temperature. So is that cold? Yeah, that's pretty cold. only do you have to be able to do order of operations, like the one we just did, which is the same thing we did yesterday, it just added the fractions in. But you're going to have to be able to do stuff that looks like this, and we're going to go through it 2 different ways so you can see both ways to do it, okay? So we're going to simplify this expression using order of operations. So I'm going to write this one down. What would I do first if I was doing just straight order of operations? The parentheses, right? Okay, so 3 plus 2, 5. Okay, very easy to start off here. All right, now what would I do? Yeah, multiply these two together, so what's negative 5 times 5? Negative 25, good, plus negative 4. How much was that? You just add them together, good. So negative 29, okay? So that is one way to solve these. But there's another way to solve them, what's called using distributive property. We will use distributive property now from today for the rest of your math career, okay? So this is another way to do it. I would have to say it doesn't always make sense to do it this way. So this is just, I called another tool in your toolbox, okay? All right, so we're going to start with the 5 here. Okay, so what operation is going on between this 5 and that parenthesis right there? What operation is it? Multiplication, right? Okay, so watch what I'm going to do. I'm going to say this times this. What is negative 5 times 3? Negative 15, good. Okay, I'm going to keep the plus sign and do what's negative 5 times 2? Negative 10. Now, look back to what we did a second ago. Is that the same thing as this? It is, right? Because this is negative 25. What's these two together? Negative 25. Do you see how they're the same? I just did it differently, but it's the exact same thing. And now I'm going to go ahead and still add the negative 4 like that. You guys see it? It's just broken into 3 pieces instead of 2. That will become way more helpful when we start doing algebra. Okay, so now I'm going to just go ahead and add these two together and get negative 25. Oh, look, it's the exact same thing, exact same answer, just a different way to do it. Okay, all right, we're going to practice this distributive property score. All right, so digits is going to make sure that you understand distributive property, because I think, is this the first time you've ever seen this? Okay, some of you saw it last year, and some of you are like, no, yes. Some of you don't know you're in math class right now. That's Nelson. There we go. There he is. Okay, so they're going to want you just to write the expression, okay? So you don't even have to solve this one. You just have to rewrite the expression using distributive property, okay? So distributive property is going to say I'm going to take this times this, and this times this. So now look through these 3. Which one shows that? First one, second one, or third one? That's the question. I think the first one. What did the first one forget to do? Okay, this one they forgot. They have to do it to both. So they did it to this one, but they didn't do it to this one. So this one's out. Okay, so let's check. This one, this they multiplied here. What did they forget to do here? Add the negative part to it. So it's not this one. So let's check this one. They took a negative 6 times the 1/2. That's correct. And then a negative 6 times a 1/3. So this is the one that is the same. Does that make sense? Yes? Is it okay? Okay. I thought you guys would have been way more pumped up after that volleyball game. Way more excited. Now, let's see, you're rubbing your eyes. What's wrong with you? I'm tired. Tired?
And it's Friday too.
It's Friday, I know. You guys should be good. All right, here's another one. So which expression is equivalent to, and what is the value? So it's going to make us do both this time. All right, so this one's a little bit harder. So again, you want to make sure that you're taking this negative 10 times this, and negative 10 times this. It has to go to both. Okay, so to this one says negative 10, and then it's got times 5.8, and then what did they do wrong on this one? Can you see it? They forgot to add the negative, because they said they kept the minus, which is right here, but then they made it a positive 10. So look at this one. Negative 10 times 5.8. They did that. Here's the minus. Here's the minus. And then they said negative 10 times 6.2. Okay? So let's see. Order of operations tells me I have to use multiplication, right? So I'm going to multiply 10 times 5.8. Sorry, negative 10, which means I only have to move the decimal point, right? So I don't even have to pick up a calculator. What is negative 10 times 5.8? Negative 58. Good. Negative 58. All right. Minus. Now I have to do the other multiplication, right? All I did was took the minus down. Now I have to do this. Again, I should be able to do that in my head. What's negative 10 times 6.2? There you go. Okay, so everybody cool with that? What do I have to do with all subtraction problems? Same, change, change. Very good. So, same, change, change. And now I have to subtract them because they're different signs. So, 62 take away 58 is what? 4? And is it positive or negative? Positive because 62 was bigger. That would mean I owe someone $58. I had 62 in my pocket. I'll have $4 left over. All right, next part of this. There's a lot of stuff to this. Okay. I don't think, hopefully, you're going to find this too crazy hard. These are called complex fractions. Okay? Complex fractions basically mean you have a fraction inside of a fraction. Okay? We can't have fractions inside of fractions. But what have I taught you about a fraction bar? It's really a dividing sign. So what this problem really is negative 3/4 divided by 10. Are you able to solve things like that? Yes. Yeah, because I've shown you how to do it. Does that make sense? So that's all we're going to do. We're going to get rid of fractions inside of fractions. Okay, so let's look at a problem. Okay, and I don't know if you guys have seen these. I don't see these around here as much. I grew up in a town called Hannibal, and Hannibal sits right on the Mississippi River, and the Mississippi River is about at least double the width of the Missouri River. So when you guys see the Missouri, it's like twice as big. It's very large. And people in my hometown use it like a lake. And they boat on it, they fish on it, they water ski on it because it's very large. I don't know if I'd swim in it that much, but they do water ski on it. Okay, so what this is saying is when boats come in, they have these, what they call, these little things, I don't know what they're called right there. But they take those gates and they put the boat in, and then they'll actually lower the water down and then let them out on the next part. And it's pretty cool. You can go along and you can see them all along. I think they're called locks and dams is what they're called. And you can see them all along the river. There's several of them. So that's what this one's talking about. And it's saying the water level drops 3 feet every 2.5 minutes. Okay, so every 2.5 minutes it goes down another 3 feet. Every 2.5. Okay, so they're saying rewrite the complex fraction as a division expression, then simplify. Okay, so this is saying negative 3 over 2.5. What did we just say the fraction bar was? A division. So we're just going to change it to negative 3 divided by 2.5. What do we have to do so we can divide those? Go ahead, Kendall. Very good.
And then change it to a
Improper fraction, good. So 2 times 2 is 4 plus 1 is 5. So I'm going to change this to negative 3 over 1 divided by 5 over 2. And then I taught you guys this before. You just do keep, change, reciprocal. Keep, change, flip is what I call it. Okay, so keep the first one, change the multiplication, and flip the second one. And then multiply straight across the top, straight across the bottom. So negative 3 times 2 is negative 6 over 5. 5 goes into 6 one whole time with 1 left over. And we have negative 1 and 1/5. It's the exact same thing I've already showed you. I've already showed you how to do this. They're just putting a fraction within a fraction. That's it. Okay? All right, I would like you guys to try this one on your own. All right, so the last thing I need you guys to know, and this is more of a just a need to know. If you would get an expression like this,